afternoon, dear participants of the conference. I want to present you a report, Algorithmization of Intellectual Data Analysis for Measuring the Country's Innovation Potential. The author of the study are Serhii, Naukova, Nataliya, Olena, Mudryi, Vasyl, Nataliya, and I, Daria Davidenko. The relevance of our research is shown on the first slide. The purpose of the research is to develop an algorithm for determining the country's innovation potential using applied intelligence system based on the identifying influencing factors and uncovering hidden relationship between variables and statistical data. To achieve the stated goal, the following tasks were addressed. Formulation of the inaugural set of indicators of innovation potential based on analysis of literature sources. Proposal of an algorithm for determining the level of innovation potential, which included a identification of hidden relationships between variable by construction and correlation metrics. B. Selection of the most representative indicators using the principal component analyzing method, and C. Calculation of the resulting integral indication using the taxonomic indicator of development method. Analysis of publication. The work examines the publication of many Ukrainian and foreign scientists who researched the issue of determining the innovative potential of the country and its economic modeling. The research algorithm and method used are shown in figure 1. The next slide shows the initial data for conducting the study. There are indicators of the innovating native potential of Ukraine for 20 years. Experiment for eliminating the multiplicatory effect between the indicators and metrics of previous correlation. Coefficient was calculated, which is presented in figure 2. To address multicollinearity, further factor analysis is conducted to determine the optimal set of indicators for assessing the level of innovation potential in Ukraine, incorporating 6 indicators. For practical implementation of the principal component analysis method using the data provided in figure 2, the staff graphic Centurion 19 package was utilized. This package allow for the examination of individual and cumulative variance. The proportion of total variance explained by each component and cumulative variable variance characteristics the selected principal components. Figure 3. The obtained results of the factor analysis for indicators of innovation potential are presented in figure 3, where the necessary number of factors are determined by the magnitude of cumulative variance. A value of cumulative variance at the level of 16% is considered sufficient. This indicates that the formed factors explain of the variability of the studied process will 13% is explained by the other factors. The results of the factor analysis demonstrate that is advisable to conduct an assessment of the country's innovation potential based on 3 obtained factors, which explain 84% of the variability of the assessment. result. As seen in Figure 4, the highest values of Ukraine's innovation potential were in 202, 216, and 221, while the lowest were in 25, 28, and 20. 11. The provided statistics allow for the identification of fluctuation in the country innovation potential over time. However, for a qualitative interpretation of the assessment results, there is a need to develop a scale for distributing indicators at the level. The research proposed a scale for determining the level of country's innovation potential based on the Fibonacci ratio. Uh, and the obtained interval 0, 0, 3A2 is divided into two smaller intervals at the levels of 38% and 61%. As see from Figure 5, starting from 2012, Ukraine has had an average of sufficient level of innovation potential, largely driven by significant technological development in sectors such as information technology, agrotechnology, biotechnology, and energy efficiency. Some Ukrainian IT companies have gained recognition in the global market, indicating the country's potential in this field. Additionally, Ukraine has significant potential in the scientific sphere with numerous research institutions, universities, and research centers. However, the effectiveness of transforming scientific development into commercially successful innovation is insurance due to various reasons, such as the lack of infrastructure for technology transfer and weak protection of intellectual property. Conclusion, the researchers developed as an algorithm for determining the integral indication of the country's innovation potential through a system of quantitative indicators by selecting the initial set of indicators based on this science of methodological approaches in the science literature, eliminating high functional development between indicators using correction analysis, reducing the number of coefficients using multi-dimensional factor analysis principal component method as the initial data for conducting correlation and multi-dimensional factor analysis were derived from a sample of 22 observations. Based on the result on factor analysis, it was established that it is advisable of assess the innovation potential basis on three obtained factors, which collectively account for 84% of the variability on for the initial variables. Amount set of indicators for each factor diagnostic features were determined using the well-center method, which have the most significant properties of the set of output data. Based on the taxonomic indicators of development, integral indication of Ukrainian innovation potential for 2010 and 2021 were calculated, and their qualitative interpretation was provided according to the scale development basis on the Fibonacci relationship. The proposed algorithms allows for conditional monitoring and control of innovation potential, identifying forecasting risk and potential issue, as well as determining possible ways to address them. Thank you for attention.